Hello, my name is Miss Cled. I hope you guys are having a great day. If you guys have any questions, please ask them after the videos and such. This is going to be at your own pace, so if you need to pause this, please do so. Let's talk about the different essential questions that we're going to see in the set of notes. So, what is a rock? What are the three types of rocks? And how are they formed? Those are going to be like the three main ones that we're going to look at. So rocks are a solid mass of minerals or mineral-like materials. So they're going to have like your solid, your crystalline structure, your chemical composition. They're inorganic, and on top of that, they are naturally made. Now, igneous rocks form from cooling of magma or lava. Both of them are considered the same thing, but the overall general part from the overall part from where these two come from is called molten rock. Now I'm going to quickly pause my camera for a second. So extrusive, like the two different types of igneous rocks that we're going to classify them as, is extrusive, which are going to happen above the Earth's surface, or intrusive, which is going to happen below the Earth's surface. Extrusive is going to have lava. Intrusive is going to have magma. Both are from the same thing, molten rocks. Extrusive is going to have a fast cooling rate, meaning it does not have the time to let the crystals grow. They're going to have more of a smoother, glacier type of textures or minerals, and you have a hard time seeing them. So you're going to have to look at them in a microscope. Intrusive is going to happen below the Earth's surface, has a cooler rate, meaning that it's going to have more time for the crystals to grow. Texture is going to be more of a rough type. You're going to be able to see these crystals a little bit better. So extrusive outside the Earth's surface, intrusive inside the Earth's surface. And if, to be able to put this into perspective and such, if we were to take you guys outside right now in the cold, like in the middle of winter without jackets on, you would cool off faster, meaning that you're going to have smaller pores on your skin. Whereas if you were cooling off inside, you're going to be able to see the pores on your skin a little bit better because you've had more time to cool off and your body has had time to adapt. So let's talk about the different types of other types as well. And that is going to be like felsic, which is rich in silica. The less dense the atoms are, the more lighter it gets, the lighter it is, the lighter the rocks are going to be. They're going to be more slow moving. So if we want to talk about the different types of volcanoes, we're going to talk about that a little bit later. However, slow moving, they're higher, thicker viscosity. They have more minerals that are less dense. These are going to be your light-colored igneous rocks. So they're crystallized in light-colored minerals, results in rocks with low density. They're going to be mostly your continental ones, so like your granite, your rhyolite, and I will show you guys in person these different types of rocks. Whereas mafic are going to be your dark-colored igneous rocks. And they're going to have more of the heavier, denser atoms and such inside the rocks. These are going to be faster, thinner, viscosity, meaning less, the more resistance or less resistance. Again, dark colored, they're going to be more dense, meaning these are the ones that possibly will sink later. And we're going to talk about the difference between these two different rocks and how they impact our planet. So here we have the igneous rock cores, rock charts. I will go over more of that here soon in person. However, you're going to have yourself like the obsidian, which is going to be really glassy-like, versus a pegmatite, which is going to be very coarse but darker, lighter colors. Now, on your four corners, I would like you guys to finish filling this out. I just wanted you guys to get started, especially with answering these two. The extrusive is going to happen outside. Intrusive is going to happen inside. And again, I will have this up on Canvas. Let's talk about sedimentary rocks. Sedimentary rocks form when layers of weathered, eroded, and deposit sediments contain evidence of past conditions and events. So we got 5 different steps as to how the sedimentary rocks form. We have weathering, erosion, deposition, compaction, and cementation. Weathering is breaking down the rocks. And in the next set of notes for weathering, we're going to be talking about the different types and how they affect the rocks and soils. But weathering is breaking down the rocks. Erosion is taking all the rocks that have been broken down and picking them up and carrying them away. So they're going to be the ones that are going to take all these sediments and they're going to take them to somewhere else. Deposition is when the sediments get dumped out into whatever has carried or transported them. And this is when whatever is transporting them, whether it be wind, water, or glaciers, or animals and sorts, is going to lose the energy and again drop the sediments, what is carried. And whatever happens, the more we compact down, this is the 4th step, all the sediments that get packed down get layered on top of layered, and it's going to start squeezing out any little water that's left out in there, any little thing that kind of helps glue these sediments together. But all that is going to start piling down. So if we had about 1 or 2 people dogpiled on top of you right now, the pressure is not going to be too bad. The more people we keep adding onto you, though, being dogpiled, you're going to start feeling that pressure at the bottom. So eventually what happens after you get dogpiled and such, and you have about 20 people on top of you, good luck, you're going to have cementation, which is when all the minerals that are deposited get binded together. Like you're going to be stuck to them. So it's going to be like, there's going to be some people in that dog pile that's going to be like kind of stuck to you a little bit. Not completely, like you can get unstuck. But I mean, these sediments are going to be stacked on top of each other and they're going to be hard to break apart. That's the 5 steps that it takes for all sediment or sedimentary rocks to occur. Now, sedimentary rocks isn't just one type of rock. It's multiple different types of rocks that are combined together or minerals combined together. We're going to talk a little bit about the difference between each of these type of sedimentary rocks. So the 3 different types of classifications, you got clastic. And these are when you got all these different fragments of rocks combining together and it's based on size. The bigger they are, the bigger the rocks that you can see and be able to tell, hey, this is where this rock's coming from. What's this rock telling a story of? Smaller they are, the harder it is. So again, pebbles are either round or angular. Rounded are conglomerate, angular are breccias. 2 milliliters or 2 millimeters or bigger. So it's going to be like from where where my pinky is to where my fingernail's at. That's about how big it's going to be. So anything bigger than that, that's considered a pebble. Sand smaller, silts get smaller yet, and clay is the itty bitty teeny tiny things that you can't see. Chemical sedimentary rocks is when all the sediments from a certain rock or any type of kind of rocks gets dissolved out from that rock and forms together whatever, going through the steps of sedimentary, and gets directed out from water. And you're going to see that a lot with limestone, siltstone. You're going to see a lot of those. And then biochemical sedimentary rocks are made of sediments derived from plants and animal remains from millions of years ago. Now, this kind of goes slightly against what it says for minerals. However, over millions of years, all the things that was once made that organic material gets sucked out or leached out. And what gets replaced with it is or inorganic material. So rock sediments or minerals that get moved into the bones that were once animals or plants. Now, each of these are very different. Each sedimentary rocks tells a story. These are great to be able to tell us what has happened in the past. So you can see the fossils, ripple marks, mud cracks. We can be able to tell okay, at one point this was once underneath ocean, or at one point this was right next to the beach and such. Or it could be at one point, this was all desert land and it gets compiled together and now it's not a desert land. Things change, but sedimentary rocks tells us a story. And these also kind of help, like we can't be able to tell, like we can kind of tell based on the traces of life and everything on radioactive decay, and we'll talk about that later when we come to geological history. But knowing the relative age of sedimentary rocks is helpful to be able to tell like what has happened. Like we can see based on geological history, like what has happened with certain animals, why they're still continued, why there's been evolution, or why there's been some extinction. So and it tells us the formation or the environment that it preserves that energy, like the information that we need to know about what has happened in that environment. Here is the chart to be able to kind of have an idea as to what type of sedimentary rocks we're looking at and what kind of information that is given to us. Now, on your four corners, I would like you guys to please write this stuff down, and then you will fill this out in a little bit. Metamorphic rocks, the last type of rock that we're going to talk about. It is formed when rocks are altered by heat and pressure. So heat and pressure is the name of the game when it comes to metamorphic rocks. And this could be for igneous sedimentary rocks or even metamorphic rocks itself. So the two different types of metamorphic rocks are contact metamorphism and regional metamorphism. Contact is the direct touch of that area, like from either heat or pressure, and usually either both. And it does result in changes in the parent rock around that area. So in this picture, we can see there has been some sort of contact metamorphism because of the heat and all the pressure put onto the magma or in around the magma. Regional happens when there's been some sort of pressure occurring. Example, like usually during mountain or land building. That's when there's like been pressure because there's changes going on into the rocks, that there's been pushing and pulling and stretching apart, but there's pressure to it. And again, metamorphic rocks are made from heat and pressure. Now again, agents of these: heat, temperature needed to break the rocks. It has to be huge. And I mean, we will not be able to handle it. This is well above 500 degrees Celsius. And that's, definitely 500 degrees Celsius or more, but definitely well over 500 degrees Fahrenheit, more like about 1,000, give or take. Pressure is when there's so much that you start changing. Like if you had enough pressure on you, your body will start changing and morphing depending on where you're at. Especially if you go deep into the ocean and all that pressure on top of you will start changing the physical form of your body. Same thing with rocks. The pressure of rocks will change based on how deep this is and what's the pressure going on, like if there's any pushing or pulling going on with these rocks. Now, to classify the different types of metamorphic rocks, we got foliated, where we can see the layered lines, whether that's 100% straight or somewhat crooked like this gneiss here. And they're going to show like the direction in which the pressure was occurring. So we can see based on all this that the pressure is coming down here and from here because all the layers are nice and even. They will form wherever that pressure is going to be at, like where the pressure is going towards. Non-foliated means that there's no band layers, but there has definitely been some sort of heat and pressure occurring, and everything just kind of morphed together. Here we have our chart, again, giving us the information that is needed where these type of rocks are coming from. For example, like gneiss definitely is from granite, from igneous rocks. And they'll tell you some of the stuff like metamorphism. Marble is a metamorphism of limestone or dolostone. And on your four corners, I would appreciate if you guys could start filling in this part as well. You will be filling in this in a couple of minutes. There is also a backside to all three of them. Last but not least, let's talk about the rock cycle. Rock cycle is the model that describes the way in which the rocks transform to one to another. Now, I'm telling you guys now, As I have said multiple times, science is never one straight, direct, easy path. However, we can at least have multiple different ways on how things work. Rocks are the same way. Rocks don't have going from being cooled off by magma into igneous rocks, then get broken down by weathering and erosion by sediments, which then eventually through deposition, compaction, sedimentation, we have sedimentary rocks, and then eventually through heat and pressure gets metamorphic and then back again. No, as you guys can see, this goes into multiple different ways. There's no one true path as to the way and how a rock moves or changes its form. So on your paper, I would appreciate it if you guys could write down this on your four corners and define the rock cycle. If you have any questions, please talk to me right now or right after you get done with this video. And as always, I hope you guys have a great day. Bye.